From curious to knowing, a grade 4 teacher in a primary school is about to teach a lesson on ecosystems. She has rolled up the rug. She has pushed the desks against the wall. In the middle of the open floor, she has placed a ball of yarn the size of a grapefruit. Each child has a card hanging from a string around their neck. One child is the sun. One child is a frog. One child is a heron. One child is a dragonfly. One child is bacteria. One child is the mud at the bottom of the pond. The teacher says, Hiteshi, we are about to build a pond. Stand in a circle. Hold your card so everyone can see. Now think about your card. Who do you depend on? Who depends on you? When I give you the yarn, you will pass it to anyone you need or anyone who needs you. You will not let go of your end. You will hold the string and pass the ball. She hands the yarn to the sun. The sun passes it to the algae. The algae passes it to the fish. The fish passes it to the heron. Within 5 minutes, 12 children are connected by a complex web of yellow yarn that crosses the carpet in every direction. The pond has been built. Now the teacher says, a new chemical has been put into the pond. It kills all the frogs. Frog, sit down, drop your strings. The frog sits. The strings she was holding go slack. The fish she fed feels a tug. The dragonfly that fed her feels a tug. The bacteria that decomposed her body feels a tug. 3 children feel the string slacken in their hands. The pond is visibly different. The whole web has been altered by removing one node. A child says, wait, the dragonfly is still standing, but he is not connected to anything that eats anymore. Is the dragonfly going to die now? Another child says, what about the mosquitoes? The frog ate them. There are going to be a lot more mosquitoes. Another says, there will be more dead mosquitoes everywhere. That is going to be gross. The class is no longer reading about ecosystems. The class is feeling them with their fingers, with the slack in the yarn. This is what investigation looks like when it is done well. It is not students at desks looking up answers. It is students in motion, with their hands and bodies and eyes, gathering evidence about a question that matters to them. And what comes after the investigation is not a worksheet. It is an organizer, a grid, a chart, a visual structure that takes everything they just discovered and turns it into a pattern they can see. These two phases, investigation and organization, flow into each other so naturally that I want to treat them together. The investigation gathers the raw material. The organization sorts the raw material into a pattern. Without the investigation, there is nothing to organize. Without the organization, the investigation drowns the student in detail. Together, they take the student from being curious to being knowing. What investigate means? Investigation is a phase of a concept-based inquiry lesson in which students gather evidence about the concept. Notice the word gather, not receive. The student does the work. The teacher is no longer the central node in the room. The teacher has become a curator, a coach, a resource. The students are the actors. What students gather depends on the discipline. In science, they run experiments. They make measurements. They observe phenomena. They handle materials. In history, they read primary sources. They examine artifacts. They compare accounts. They interview people. In language arts, they close read texts. They listen to speeches. They watch films. They analyze character moves. In mathematics, they manipulate numbers and shapes. They build tables of values. They run patterns until something gives. In the arts, they study works produced by others. They listen, they look, they imitate, they critique their own attempts. The form of investigation changes by subject. The function does not. In every case, the student is gathering evidence about the concept they began to build in the previous phase. The concept is the lens. The evidence is what the lens reveals. There is one rule that holds across every subject. Students must investigate multiple cases, not one. If a student investigates only one case, the generalization they reach later will be brittle. They will see the rules of that one case and mistake them for the rules of all cases. A class that studies only the French Revolution will think that every revolution involves the execution of a king. A class that studies only photosynthesis will think every energy transfer involves chlorophyll. Multiple cases are not a luxury, they are a requirement. 3 cases is a minimum, 4 or 5 is better. The concept emerges from the cases, but only if there are enough cases for the pattern to show. This is one of the deepest changes between traditional teaching and concept-based inquiry. The traditional unit on revolutions teaches one revolution thoroughly. The concept-based unit teaches 3 revolutions comparatively. Less depth per case, far more pattern across cases. The conceptual gain is enormous. The teacher's job in this phase, in the investigation phase, the teacher does something difficult. The teacher disappears, mostly. The teacher has already done the heavy work before the lesson started. The teacher chose the concept. The teacher selected the cases. The teacher gathered the resources. The teacher designed the questions students will encounter. The teacher decided whether the investigation would be a lab, a station's rotation, a jigsaw, or independent research. All of that is the teacher's craft, and it lives in the planning. Once the lesson begins, the teacher steps back. This does not mean the teacher is absent. The teacher is present. The teacher is moving. The teacher is listening. The teacher is asking questions. But the teacher is not delivering content. The teacher is not at the front explaining. The teacher is among the groups, leaning over shoulders, asking, "What did you find? What is that telling you? What is that not telling you? What do you want to test next?" The teacher's job in this phase is twofold. The first job is to curate the right resources at the right time. Not too many, not too few. Resources that point at the concept without telling students what the concept is. A primary source dossier with one image, one short excerpt, and a few numbers. A data table with 3 rows and 4 columns. A short reading paired with a short film. A station with a balance and a graduated cylinder and a piece of foil. The curation looks effortless when done well. It is the result of careful design. The second job is to coach, to ask better questions, to redirect, to resist explaining. When a student says, "I do not get it," the temptation is to explain. Do not. Ask, "What do you have so far? What is the part you do get? What is the specific question you would ask if you knew who to ask?" Usually, the student will work it out within their own next sentence. Sometimes they need a hint. Give the smallest hint you can. Then step away. Let them keep working. There is a useful self-check for teachers in this phase. Ask yourself, who is doing the thinking right now? Me or them? If the answer is me, you're doing too much. If the answer is them, you're doing it right. Investigation across the disciplines. Let me show you what investigation looks like across 5 different subjects in 5 different grades. A grade 4 mathematics teacher is teaching the concept of fair sharing. She does not give students a worksheet of fraction problems. She gives them a basket. The basket contains 5 chocolate bars and a sticky note with a question: 8 children want a fair share. Show me how. Students sit in groups of 4. They have scissors, they have rulers, they have the chocolate. The first move is always the same. Someone tries to give each child a whole bar. There are not enough bars. Someone tries to break the bars in half. There are not enough halves. The students begin to chop the bars more finely. Some groups give each child 5/8 of a bar. Some give each child half plus a smaller piece. Some children get nothing but crumbs at first, which is unfair. So the system breaks down and they start over. The teacher walks around. She does not solve it for them. She asks, "Is your way fair? How do you know? Could you do it differently?" A grade 7 biology teacher is teaching adaptation. She does not lecture about Darwin. She runs an experiment. Each student in a group of 4 is given a beak. One student has tweezers. One has chopsticks. One has a plastic spoon. One has only their bare hands. On the table are 3 foods: small, slippery seeds, long, rubbery, gummy worms, a dish of the water that requires a scoop. The teacher sets a timer for 60 seconds. Each round, the students must collect as much of one food as they can with only their tool. The data table fills in fast. The tweezers win at seeds. The chopsticks win at worms. The spoon wins at water. The hands lose at everything. By the end of the second round, the students are pointing and saying, "Look, the tweezers cannot pick up worms. The spoon cannot pick up seeds. They can only eat what their beak fits." That sentence is biology. That sentence is everything Darwin spent 40 years writing. A diploma history teacher is teaching the concept of revolution. She does not lecture on the French Revolution. She runs a jigsaw. The class is divided into 3 expert groups. One group studies the American Revolution. One group studies the French Revolution. One group studies the Arab Spring. Each group receives a mini dossier. The dossier contains a 4-sentence summary, one primary source excerpt, one image, and a by the numbers panel with key dates and population figures. The groups have 18 minutes to fill out an expert sheet with 4 boxes: trigger, ideology, leadership, outcome, then the group's jigsaw. The class reshuffles so that each new group has one expert from each revolution. Each expert teaches the others. 3 revolutions taught by 3 peers in 12 minutes. The class now has comparable data on 3 cases. The pattern is about to emerge. A grade 9 language arts teacher is teaching the concept of characterization. She does not give a vocabulary handout. She gives every student the same short passage from a novel. 2 paragraphs in which a character we have never met enters a room. The students have 10 minutes to list everything they can infer about this character from the 2 paragraphs alone: age, mood, status, class, education, relationships. By the end of 10 minutes, the class has produced 40 different inferences from the same 2 paragraphs. The teacher then asks, which inferences are supported by direct evidence? Which are interpretations? Which are projections? The students sort their inferences. They learn, by doing it, the difference between description and interpretation. They learn what a writer does with detail. A grade 5 visual arts teacher is teaching the concept of contrast. She does not write a definition on the board. She places 3 prints on the front wall, 3 pairs of contrasting works. Each pair shows 2 artists handling the same subject in opposite ways. The students have a print, a clipboard, and a few minutes. They must write down everything they see as opposite between the 2 works: light versus dark, soft versus sharp, crowded versus empty, warm versus cool, movement versus stillness. The list grows. By the end of 15 minutes, the class has surfaced almost every formal element of visual art. The teacher then asks, why might an artist choose contrast? What does it do to the viewer? The investigation has built the vocabulary. The conversation will turn the vocabulary into a concept. 5 subjects, 5 grades, 5 different sets of materials, but the same essential move in every case. Students gather evidence about cases. The teacher orchestrates. The students do the thinking. What organize means. The investigation produces a lot of data. 12 children with strings in their hands. A data table with 20 rows of beak measurements. 3 dossiers of revolutionary history. 40 inferences from a single passage. 6 paintings worth of contrast observations. This data is precious. It is also in raw form useless. The student's working memory cannot hold all of it. The brain cannot run a comparison across three cases unless the cases are made comparable. The pattern cannot emerge unless the data is structured. This is why we organize. The organization phase is the bridge between gathering evidence and articulating a generalization. It is the phase where students take what they have found and make it visible to themselves, visible to each other, visible to the teacher. Without organization, students who have just finished a rich investigation will sit down in front of a generalization task and freeze. They will say, I do not know what to write. They are not lying. They genuinely don't know. Their data is in their notebooks, in their hands, in their memories of the lab. But it is not in a form they can synthesize. The organizer solves this. The organizer is a structure that lets the human brain do what it cannot do unaided. The organizer holds the data in a stable form so the brain can run patterns across it. In cognitive science, the underlying idea is called cognitive load theory. Working memory is limited. The brain can hold only a few items at once. If you ask a student to compare 3 revolutions across 4 dimensions, while also asking them to remember the facts of each revolution, while also asking them to articulate a pattern, you're asking too much. The brain cannot do all 3 at the same time. It will drop something. Usually, it drops the pattern because the pattern is the most abstract task. Without the pattern, the lesson fails. The organizer removes the load. The facts of each revolution sit in the cells of the chart. The student is no longer responsible for remembering them. The student's working memory is freed. The student can now do the one thing that matters. Look across the rows. Find the pattern. The organizer does not teach. The organizer frees thinking. The cross-comparison chart, the single most useful organizer in concept-based inquiry, is what we call a cross-comparison chart. It is a simple grid. The columns are the cases. The rows are the dimensions. The cells hold the findings. Let me show you the grade 8 revolutions chart because it is the cleanest example of how the chart does the work. Across the top, 3 columns. American 1776, French 1789, Arab Spring 2010 to 2012. Down the side, 5 rows. Trigger, ideology, leadership and mobilization. Outcome, did it deliver what it promised? The students have just finished the jigsaw. They have the data. They fill the cells. They use sticky notes in 3 colors, one for each revolution, so the columns are visually distinct from a distance. When the chart is finished, it looks deceptively simple. 15 cells filled with short answers. But the moment the students stand back and look at the chart as a whole, something extraordinary happens. The pattern jumps out. They can see in a single visual sweep what is common across all 3 revolutions and what differs. The trigger row tells one story. The outcome row tells another. The did it deliver row tells the most surprising story of all. The American Revolution mostly delivered. The French Revolution partly delivered after enormous bloodshed. The Arab Spring, delivered in Tunisia, was undone in Egypt, collapsed in Libya, descended into civil war in Syria. 3 revolutions, same conditions, very different outcomes. That last observation is the engine of the lesson. The students see with their own eyes that outcomes depend on what is built, not on what is overthrown. They could not have seen this from any single revolution. They could not have seen it from 3 lectures. They saw it from the chart. The chart was the lens. The pattern was the gift the chart gave them. This is why we use the cross-comparison chart. It is not decoration. It is not a worksheet. It is the structural device that makes the conceptual move possible. Another cross-comparison, the density lesson. Let me show you a cross-comparison chart in a different subject. The grade 8 physics class with the 2 soda cans. After the investigation, students have data on multiple objects. A diet cola can, a regular cola can, a wooden log, an ice cube, a marble, a steel bolt, A piece of aluminium foil, flat. The same piece, crumpled tight. They have measured mass and volume and density for each. They have predicted float or sink. They have tested. Some predictions were correct. Some were spectacularly wrong. The teacher puts up a cross comparison chart. Across the top, the column headers. Object, mass, volume, density, floats. Down the rows, the 8 objects. The students fill in their data. The chart fills slowly. As it does, the pattern starts to show. Everything with a density less than 1 floats. Everything with a density greater than 1 sinks. There is one strange case. The aluminium foil. Flat, it floats. Crumpled, it sinks. Same material, different shape, different density of the configuration. The chart makes this anomaly visible. Without the chart, the anomaly would have been lost in the noise of the lab. Now the teacher adds a final row. A steel ship. The students laugh. A steel ship cannot fit in the chart. But the teacher has put in the numbers. The mass of a small ship is enormous. The volume, including the air inside the hull, is even more enormous. The density, when calculated, is less than 1. The chart shows it. The ship floats. The same rule applies. Steel sinks because steel is dense. A ship floats because the average density of steel plus the air inside the ship is less than water. The chart has just bridged the lesson to the rest of physics. That is what an organizer does. It builds the bridge from the specifics to the principle. Other useful organizers. The cross-comparison chart is the workhorse. But there are other organizers worth knowing. The Venn diagram is good when you have 2 cases and you want to surface what they share and what they differ on. 2 circles overlap. What is in the overlap is shared. What is in each non-overlapping section is unique. A primary teacher comparing 2 characters in a story might use a Venn. A history teacher comparing 2 political systems might use a Venn. A maths teacher comparing 2 geometric shapes might use a Venn. The Venn is simple, but the simplicity is the point. It makes shared features and differences obvious to the eye. The concept map is good when you are setting at a single concept with many subordinate ideas. A central node. Lines branching out to related ideas. Connections between the branches. Concept maps are particularly powerful in subjects with many interrelated ideas. Ecology, sociology, literary genre, physics units. A student who has built a concept map at the start of a unit and rebuilt it at the end can see, by comparison, how their understanding has changed. The map at the start is sparse. The map at the end is rich. The visible difference is the lesson made visible. The T-chart is the simplest organizer of all. 2 columns, 1 topic per side, topic versus theme, cause versus effect, topic versus argument, hypothesis versus evidence. The T-chart is good when you want to sharpen a single binary distinction. It is not a deep organizer. It is a clarifying one. The 4-quadrant chart, like the Freyer model we met in the last chapter, is useful when you have 4 related but distinct dimensions of a single concept. Definition, characteristics, examples, non-examples. Some teachers use a slightly different 4-quadrant chart with the headers looks like, feels like, sounds like, is like. The variation matters less than the principle. 4 cells force the student to consider 4 sides of an idea at once. 3 is too few, 5 is too many. 4 is the sweet spot for a brain that wants to consolidate without being overwhelmed. The matrix or grid is what we have been calling the cross-comparison chart. It is the most useful of all the organizers and the one most teachers underuse. You can run it on 3 cases, 4 cases, 5 cases. You can run it on 3 dimensions, 4 dimensions, 5 dimensions. The grid scales. The grid sees patterns. One rule applies to every organizer. Decide on the organizer before the investigation starts. Hand the empty organizer to students at the beginning of the investigation, not at the end. This is counterintuitive. Most teachers wait until the investigation is over and then introduce the chart. By then, the students have not gathered the right data. They missed details that would have filled the cells. They notice things the chart does not record. The investigation is rich but disorganized. The chart cannot be cleanly filled. Better to give the chart at the start. The chart guides what students look for. The chart says, these are the dimensions that will matter. The investigation is more focused. The data is more comparable. The pattern is more visible. Why we organize before we generalize. I want to be explicit about why this matters. Many teachers run an investigation and then ask students to write a sentence about what you learned. They skip the organization phase. They expect the student to leap from a notebook full of observations to a clean generalization. The leap is impossible. The brain cannot do it. The data is too scattered. The pattern is not yet visible. The student writes either a single fact dressed up as a principle or a vague platitude that says nothing. The teacher reads the sentence, sighs, and concludes that students cannot generalize. The teacher's conclusion is wrong. The students can generalize. They have not been given the structure that makes generalization possible. They are running the brain on too much load. Working memory is full. Synthesis cannot happen. The organizer solves this. Once the data is in a chart, the chart does the holding. The student is free to look across the rows. The pattern emerges. The generalization is now within reach, not given, not handed over, but reachable. The student crosses the gap. The student does the work. The organizer made the work possible. This is the unsung pedagogical move. The organizer is invisible in most reports of good teaching. The provocation is glamorous. The discussion is famous. The transfer is celebrated. The cross-comparison chart sits quietly in the middle and makes all the rest of it possible. Without it, nothing transfers. With it, everything does. Treat the organizer with the respect it deserves. Design it carefully. Use it deliberately. Hand it to students before the investigation. Let it shape the inquiry from the inside. A note on cognitive load. The cognitive science behind organization deserves a brief moment of attention. Working memory has a hard ceiling. The number varies by source, but the practical implication is the same. You can hold a few items in active thought at once. 4, 5, maybe 7 if you're caffeinated. After that, items fall off. New input pushes old input out. Now think about what we ask students to do in an investigation. Compare 3 revolutions across 4 dimensions. Recall the facts of each revolution. Articulate a pattern across the 3. Hold the pattern in mind long enough to write a sentence. That is at least 15 items of active thought. The student cannot do it. No student can do it. The brain is not built for that load. The organizer offloads. The cells of the chart hold the facts. The columns hold the cases. The rows hold the dimensions. The student no longer has to remember any of it. The student is free to do one thing only. Look across the rows. Find the pattern. Articulate the rule. Working memory is freed for the one task that needs it. The organizer is, in a real and measurable sense, an extension of the student's mind. It is cognitive scaffolding. It does for the student what the calculator does for an engineer. It holds the routine so the human can do the creative. This is why organizers matter. They are not paper exercises. They are mental prosthetics. They make hard thinking possible. What you can do tomorrow. Design a cross-comparison chart for the next unit you teach. That is the move. Decide on 3 or 4 cases that the unit will study. The cases should be different enough that the pattern can emerge. 3 revolutions from different centuries, 3 short stories with different settings, 3 ecosystems, 3 artists, 3 historical figures, 3 mathematical functions, 3 philosophical arguments. Then decide on 4 to 6 dimensions you want students to compare. The dimensions are the rows. They should be conceptual, not merely factual. Not what year did this happen, but what was the underlying cause. Not who was the protagonist, but what does the character reveal about us. Choose dimensions that point at the concept you want students to build. Print the chart, hand it to students at the beginning of the investigation. Tell them, this is what we are going to fill in. These are the dimensions that matter. Watch what happens. The students will gather evidence with a purpose. The chart will fill cell by cell. By the end of the investigation, the chart will be complete. And when you ask, what pattern do you see across the rows? The answer will come. Try it. You do not have to redesign your unit. Just design the chart. The chart will change the unit on its own. Looking back, looking forward. In this chapter, we walked through the 3rd and 4th phases of a concept-based inquiry lesson. We watched investigation in 5 disciplines, a primary maths lesson on fair sharing, a biology lab on beak adaptation, a history jigsaw on revolutions, a literature close read on characterization, a visual arts study of contrast. We saw that investigation is the phase where the teacher disappears and students do the gathering. We named the teacher's 2 jobs, curate, coach. We met the most powerful organizer in concept-based inquiry, the cross-comparison chart. We saw how it makes patterns visible across cases. We met other organizers too. Venns, concept maps, T-charts, 4-quadrant grids. We named the cognitive science underneath. Working memory is limited. The organizer offloads. Working memory is freed. The pattern emerges. The students now have data. They have an organizer full of evidence. They are standing at the edge of an idea. They can see it, but they have not yet said it. They have a chart. They do not yet have a sentence. In the next chapter, we move into the 5th phase of the lesson, the phase where the chart turns into a sentence, the phase where students take everything they have organized and distill it into a single line that will travel with them for the rest of their lives.